Good morning, dear students. We are discussing about the colligative properties, and we have studied three of them. What are they? The first one is relative lowering of vapor pressure. The second one is elevation in boiling point, and the third one is depression in freezing point. And also we have to calculate molecular mass from these colligative properties. And the last colligative property, the fourth colligative property is osmotic pressure. In this class, we have to study what is osmotic pressure. Before studying osmotic pressure, I am going to introduce some of the terms. What is a semi-permeable membrane? A semi-permeable membrane means membrane which allows the passage of solvent molecules only. For example, animal membrane, cellulose, film of cupric ferrocyanide. So what is a semi-permeable membrane? It is a membrane which allows only the passage of only the solvent molecules. In a solution, there will be solvent molecules and solute molecules. But a semi-permeable membrane will allow the passage of solvent molecules only. It will not allow the passage of solute molecules. So that is semi-permeable membrane. The next term is osmosis. What is osmosis? The phenomenon of spontaneous flow of a solvent through a semi-permeable membrane into solution or from dilute solution to a concentrated one is termed as osmosis. Osmosis means when we separate a solution and a solvent by a semi-permeable membrane, what will happen? There will be a spontaneous flow of solvent molecules from the solvent side to the solution. So that spontaneous flow of solvent through a semi-permeable membrane into solution is called osmosis. Or it may be the flow of solvent from a dilute solution to a concentrated solution. In a dilute solution, there will be more concentration of the solvent molecules. So osmosis means the spontaneous flow of solvent through a semi-permeable membrane into solution or from a dilute solution into a concentrated one. So in osmosis, what is happening? The passage of solvent molecule from higher concentration of the solvent molecule to its lower concentration through a semi-permeable membrane. That is osmosis. You have to remember these two terms, osmosis and semi-permeable membrane. Then we are going to study our topic, osmotic pressure. Look at the figure. There is, you can see, so there is a chamber. Chamber A is fitted with a movable piston at one end. In this chamber, one end of the chamber is fitted with a movable piston. There is a movable piston at the left side of the chamber. And the right side of the chamber is an open end. And you can see there is a semi-permeable membrane which divide it into two compartments. The left compartment is filled with solution and the right compartment there is pure solvent. So chamber A is fitted with a movable piston at one end. The other end is open. The chamber is divided into two compartments by a semi-permeable membrane. The left compartment is filled with solution and right compartment with pure solvent. Then what will happen? We have already said that the solvent molecules will pass through the semi-permeable membrane from pure solvent to the solution side. Okay, that is osmosis. In this case, osmosis will take place. Due to osmosis, look at this figure. Osmosis will take place from right compartment to the left compartment. Due to osmosis, what will happen? What will happen? There is a change in the position of piston. It will move upward due to the passage of solvent molecule from right compartment to left compartment. That is due to osmosis. The piston in the left compartment will move upward. Okay. So, to maintain the piston in the original place, we have to apply pressure on the piston. That pressure is termed as osmotic pressure. So, osmotic pressure can be defined as the minimum pressure required to prevent osmosis. When solvent molecule move from right compartment to the left, the piston will move upwards. So we have to apply a pressure to maintain the piston at its original position. That pressure will be equal to the osmotic pressure. So that's when we apply the pressure, the osmosis will stop. So that pressure required to prevent osmosis is termed as osmotic pressure. So we know for an ideal gas, PV equal to nRT. P means the pressure. In this case, we are talking about dilute solution. So we can write the equation as pi V equal to nRT, where pi is the osmotic pressure. So pi V equal to nRT. where N is number of moles. So N can be written as W2 by M2. So pi will be equal to W2 RT by Vm2. From that M2 can be calculated. M2 equal to W2 RT by pi into V. So what is osmotic pressure? Osmotic pressure is the minimum pressure required to prevent osmosis.